Welcome back. I know it's been a couple days, and you've really missed it, but yes, the Parallelogram song is still a thing, and it's still your favorite jam, and I'm still here to play it for you, because you love it. Now, a lot of people whose grade is not good in my class, it could be better, let's put it that way, who say, I can only come to after-school tutoring. This is your week of no excuses and opportunity. I'll be here every day after school this week. I'm not staying till 6, but I will stay after school. Yay. If 4, 15, 20 rolls around and no one's here, I see how it is, and I'll be out of here. You know what I'm saying? So again, y'all, if you want to actually get tutoring after school, actually come to me first. Not that I don't think your other classes are important, but this is my week. Because next week is not my week. Okay? So if you need me to help you, and it has to be after school instead of before school, this is your week. Is every single living soul in this room hearing me say that? Or after the fact on the video. Okay? You need to know this. Because if your grade should improve, right now, you have plenty of time. Next week is the last week. And you're struggling at the last week, which everyone's going to have that same bad idea. Don't have a bad idea. Have a good idea. This week, let's take care of our grades. That way, we don't fail for the 9 weeks, okay? I'm telling you, this is the week you get it done. Next week is the week that you try, but it will probably be too late. No promises. There's always last-minute miracles, but I promise nothing at the last minute. But this week, I promise to you that I'll be here after school, and we will do what we can, okay? So, that being said, we're going to do some application practice based on what we did on Friday. Now, real quick, this is the front of your packet, but I don't want you to look at the front, okay? So flip it over. Look at the very top. This is the back page, okay? So seriously, the back page of this packet is what we're going to do. We're not necessarily doing more notes. I know it says notes, but I'm showing you how we would do this based on what we learned on Friday, okay? So, look at the first shape, okay? It tells us, when we read this, what it is. It says, solve for x, y, and z on the following parallelograms. All right? So, what do we know about parallelograms? I'm glad you asked, okay? So, if I can get this to not look funny, we're going to have to move this. View, page width. All right, and then we move that back up, and everything's great. Okay, so what do we know about parallelograms? Hopefully from the songs, you know, opposite sides are parallel, and opposite sides are congruent, and opposite angles are congruent. Consecutive angles add up to 180, right? So, all that to say, we're going to use that info to do these practice problems. So, we'll start with x. Like the song says, in the chorus, opposite sides are parallel, right? And they're also congruent. So, tick, tick. If I'm going to solve for x, and I've got 2 expressions with x in them, I am going to set them equal and solve for x. Okay? This is like your classic restroom problem, where you had to solve for x. So you can't forget that stuff. So, let's write that out. There's not a ton of room here, so just use what we got. So right here, 2x plus 5 equals sign 4x minus 5. So we might need to dust off the algebraic skills in our brain. What do we do when x is on both sides of the equation? Do we combine them, or do we get rid of one of them? Take a wild guess. What do y'all think? Do we combine them, or get rid of one? Okay, so we actually get rid of one of them. We combine them when they're on the same side, but these x's are on different sides of that equal, right? So I'm going to get rid of the smaller x, right? So if you're looking at your phone, don't. So, which x is smaller? 2x. So I'm going to get rid of a positive 2x by subtracting 2x minus 2x minus 2x. So that leaves me with 5 equal sign 4 minus 2, 2x minus 5. Okay, that's a two-step problem now. How do I get rid of that minus 5, that loner on the right side? The opposite is to add, so very good. Add 5, add 5. So now I get 10 equals 2x, right? Because 5 plus 5 is 10 on the left. And how do I get rid of that 2? Divide by 2. Okay. So 10 over 2 means x is going to equal 5. You're dividing by 2, right? Okay. So I know that spilled over. Okay. Oh well. Okay, now to solve for y. Now, what do I know about these angles that are across from each other? If I look, just looking at them, it's acute, it's acute, and if I go back to my properties page, okay, we know that opposite angles are congruent, right? So, that means we can set those equal as well. So let's do that. 2y plus 16 equals sign 10y. Once again, y is on both sides. We literally just did something like this, so remind me, when y is on both sides, do I combine them or get rid of one? Get rid of one of your y's, and I like to get rid of the smaller y. Which y is smaller? 2y. So to get rid of a positive 2y, I'm going to subtract 2y on both sides. Cross that out. Bring down 16 equal sign. 10 minus 2 is 8y. And how do I get rid of that 8 coefficient? Divide. So divide by 8. Divide by 8. 16 over 8 is 2. Okay. So if and when you get to something like that on your practice, okay, you'll know what to do. Now some of the ones on the practice are way easier. Okay, it already gives you the number, so the opposite is the same number, right? The degree measurement. Okay, so there's that. Now, please be careful. The one I just did were opposite angles. Opposite angles are equal. They're congruent, right? But look at this next one. These are not opposite angles. This is obtuse. This is acute. They are not congruent. The most common error I see is people setting things equal that are not equal. Okay? Now, I would call these consecutive angles. They're next to each other. So again, if we hearken back to our notes, we learned right here, consecutive angles are supplementary, which means they add up to 180. So again, if they're not across from each other, if they're kind of next to each other, those are supplementary in a parallelogram. So that's what we're going to do. We're going to take this plus this equals 180, because they're supplementary. So let's do that. So first I got 7z, 7z minus 40 plus 3z equals 180. Look how smart we are. So, class, what do we do when there's more than one z on the same side? Do we combine them or get rid of one? Combine like terms. It's like you've learned this before. So 7z plus 3z is 10z. And I know we're not playing pool in class. So let's bring down minus 40, bring down equal sign, bring down 180. All right, so now I've got a loner of minus 40. How do I get rid of that loner? Adding 40, right? So 180 plus 40 gives me 220. And then to get rid of that 10, that coefficient, we're going to divide by 10. So we should get Z equals 22. Okay? Now, that was parallelograms. Opposite sides are equal. Opposite angles are equal. Consecutive angles add up to 180. If you know that, you'll be all right. Okay? Now, down here, solve for P on the following triangles. Okay? Sorry, the following rectangle. Okay, so I know it's kind of hidden because I drew over it, but it says the word rectangle. So, it has something on an angle. This should be one of the easiest ones, but some people get stuck, so don't get stuck. Everyone, let's take a peek at our notes. What do we know about a rectangle's angles? They're 90. Whatever you see on a rectangle for the angle, set it equal to 90 and solve. That's it. Okay? Let me show you what I mean. I see it's a rectangle. I see it says 3p. I know it has to also equal 90. So 3p has to equal 90. I'm literally going to write that. 3p equal sign 90. And then you solve by whatever algebra you need to do. So I see there's a 3 in front of p. Mr. G is my name. All right, so anyways, how do you get rid of that 3 in front of p? Divide. So p equals 90 divided by 3 is 30. Congraturitos, you did it. All right? So, no. All right, so again, on the rectangle might have problems kind of like the parallelogram, where opposite sides are equal. That's still possible, FYI. But the angles, if you know they're 90, set them equal to 90. That's it. All right, down here, solve for M and R. Okay, so let's say you got one of these sweet-looking trapezoids. Okay, and we're going to go with red again. All right, so trapezoid. Now, you may or may not remember what this thing is called right here, where M is. That's a midpoint. That's a midpoint. So this is called a midsegment. Now, it'd be cool if we did a theorem about midsegment. And we did on our notes. It was the last thing. So let's take a peek at that to remind ourselves from Friday. Okay? Whoop. So, trapezoid midsegment theorem says what you do is you add up your two sides, your parallel sides of your trapezoid, and you divide by 2. Is everyone looking right here at my example? I got 9. I got 9. And I got 5. Okay? What did I do to get the midsegment? I added 9 plus 5 equals 14, and then I divided by 2, and I got 7. You're literally averaging the two parallel sides. So, that's what we're going to do here. I got a parallel side 6 with 16. Let's add them up. 6 plus 16. And divide by 2. Okay, 6 plus 16 is 22. Divide that by 2, and I get 11. Easy? I hope so. Okay? So when you get to the second page of mid-segment stuff, that's what you're going to do. Okay? All right. And the kites. Okay, you're going to have some kites on number 9 and 10. It's going to be not too hard. It's going to be great. So let me tell you, remind you actually, what we know about kites. Okay? So, looking back at our notes again, for a kite, it says it has one pair of opposite angles are congruent. Okay? There is one pair across from each other that are the exact same. So, check it out. On my kite, okay, if it's facing up like a normal kite shape, this and this must be exactly the same. So, guess what n is going to equal? 102. Okay, there's one pair, not two pairs, but one pair of equal angles. Okay, so that's 102. Now raise your hand if you think R is 72. Take that raised hand and smack your forehead because that's wrong. Okay, so that's what a kite does not have two pairs of parallel sides. So I'm telling you, these two will be the same, and then these two will not be the same 100% of the time if it's a kite. Okay, kite has different angles on the top and bottom if you want to think of it that way. So here's the question: how do I figure out angle R? Well, first of all, we need to know how many degrees are inside of a quadrilateral. So that means we might need to remember something from 219 on this little slidey board over here. Right? Do y'all remember that formula to find the sum of interior angles? Now, maybe you already know this, but in case you forgot, okay, n minus 2 times 180, right? Remember that? How many sides does a kite have? 4. 4 minus 2 times 180. Do the math. 360. Okay? So inside of every quadrilateral, square, rhombus, kite, parallelogram, diamond, strombus, whatever, okay? Everything. It's all 360, okay? So if I know three angles, and I'm trying to find that fourth angle, and I know they add up to 360, add the three you know, subtract from 360. Right? In the back on our phones? Huh? Especially if you're late to my class. It's still on your phone? What's up? What's up? Alright? Pay attention. So let's add these up. 102 plus 102 plus 72 gives you 276 by quick math. And we're going to take that and subtract that from 360, because this is a quadrilateral. And we get 84. All right, 84. So when you're doing kites, please be careful. There's one pair of congruent angles. The other two are not congruent to each other. That's what makes it a kite. Okay? So be careful when you fly that kite. So your job is flip it to the front and knock out these practice problems. They're very similar to what we've done. Obviously, some of them will be a little different. There's some challenges in there. You can do it. I believe in you. So go ahead and get started. Ask questions as needed. And this is due tomorrow. Okay, bye.